So we can take the derivative in our calculator at a specific point. So when x is equal to 2, x is equal to 3, we cannot find the derivative equation. So the calculator only evaluates the derivative at a certain x value. So we're going to go ahead and do that. What you're going to do is type in math, and then I scroll up to go to the bottom at 8. 8 is n-deriv. The first thing we type in is the function, so x to the third plus 3 to the x. Yours probably looks like the new interface where I'll post another video on that. Okay, this is the older program for the calculator, so some of you guys might have this version. Then you put a comma. The next thing we're going to put in is the variable that we're taking the derivative with respect to, so with respect to x. And then where are we evaluating at x equal to 2? Okay. Then I go ahead and press enter, and I get a value of about 21.887 or 21.888 because it rounds to this, and this is truncated, which means we just cut off any numbers past the third decimal. AP test will take either. All right, so go ahead and do the next one. I'm going to math. I'm going to press 8 for n-deriv. I'm going to type in my equation, which is the ln of x to the x squared minus 3. Okay, close that parentheses, comma x, comma, we're evaluating at 2 first, so when x is equal to 2. Oh, shoot. Okay, I'm going to go to argument, and it says that oh, I need one more parentheses. I have too many parentheses. Okay. Come on, scrolling. Okay, I'm going to delete that parentheses. Okay, enter. All right, so I get 4.0000. So g prime of 2 is equal to 4.000. All right. Another way you can do this is if we type in y equals, I'm going to type in my function, the ln of x squared minus 3. And this time on the home screen, I'm going to go to math, then to 8 again to take the derivative. This time I'm going to type in y1 since I already have the function written in. Remember, y1 is vars, y-vars, and then you select the function y1. Okay, so vars, y-vars, function. Oh, I guess you have to select 1 and then y1. Okay, y1, comma, with respect to x, comma, at 2. Same. Okay, now we're going to do the derivative when x is equal to 4. So since it's the same thing, I'm just going to put second entry. I know you guys do your scrolly thing. I'm going to replace the 2 with a 4. So same function with respect to x, and I'm evaluating at x is equal to 4. I get 0.615. Okay, or is equal to 0.615, and that is truncated and rounded. All right, to graph, this is fun. We're going to do the same thing in our y equals. So I have the ln of x squared minus 3 as y1. And then I'm going to, in y2, I'm going to type in math, n-deriv, y1, comma, x, comma, and then for all x's, okay, so instead of a certain value, we put in all x's. Now, let's go ahead and graph the original and the derivative for funsies. See what it looks like. Here's the original. Okay, that's the L-line graph. The derivative, we are slowly decreasing, okay, and then increasing on, the slopes are increasing on the right-hand side. So the graph of the, we're going to sketch this graph, looks like that, okay. If you do not want to see the original graph, just scroll over to the equal sign, press enter, and then graph again. Real cool. Another option for you is to just write in n deriv of the function. Whoa, okay, try again. N deriv of ln, you're not going to make that mistake this time, x squared minus 3, comma x, comma x. Okay, and I'm only going to graph the third function. It should look like normal old derivative. Okay. And let's go ahead and get the values of our derivative when x is equal to 2. So trace 2, enter. And we can see we have the same value, 4.0001. Trace 4, 0.615. One thing that you have to be super careful of is that the calculations, for some reason, on the home screen are more accurate than the graph. So sometimes you'll notice, like at the end of the decimal, there's some discrepancies, and know that the values from your graph are they're not quite as accurate as the ones that come from your regular old calculation screen. Okay. All right, last one. We're gonna find if f is the absolute value, find f prime of 0. All right, we're just going to calculate that. So your choice, since I'm not calculating any other value besides when x is equal to 0, I'm just going to type in the function. So the function is math number abs x, the absolute value of x with respect to x with evaluated at 0. And I get 0. But we know that the function does not exist. So again, you're going to have to be really careful here. Okay? Super, super careful. Let's do it on the graph. Okay, so second entry, I typed in the same thing. This time I'm going to put in an x instead of the 0. Graph. It's -1. And then 1, because the slope is -1 on the left, and then the slope is +1 on the right. When I press trace, I see that there is a point at 0, 0, but really it does not exist. So you have to be super careful about the sharp turns on when you use your calculator. And that is it.